Hello everybody, welcome back to the video session. In this video I am going to continue with my task 4. This is to design a simple 2-digit counter using a BCD counter, and there are standard integrated circuit is there. Using that we have to design that and to display the result in a 7-segment display. That means as we discussed in our previous task, like we learned about logic gates. Now we may need to go to next level using counters and feeding some clock signals, and also a kind of output device like 7-segment display. Now just let me move on to the Proteus demonstration page. So I'm just picking the components. I say now you can also try with the BCD counter. Yeah, you can see here these are all the CMOS ICs. So when we look for TTL, there is 74190 is there. Okay, and also we have 7490 also, I believe is a 7492 is there. Anyone you can choose, it's fine. And we go ahead with as usual LS family. Yeah, 74LS190. Okay, and I remembered as 7490 also there is a counter. Yeah, it's just a decade counter, so that also I'll just add one. And we need to have a 7-segment display. That means I just type 7-segment. Yeah, we should have actually the driver in real time, whereas in simulation environment even you can connect directly the output of the counter to the 7-segment display, whereas in real time we need to have a display driver. This is called as a display driver. Okay, we should have display driver and 7-segment. So we'll just choose it here in display. So you can see these are all the different types of 7-segment packages. Okay, so we need to choose a single digit one or 2-digit is up to you, but 2-digit is actually multiplexed and we are not in a position to use that. So we go ahead with any one of this. Okay, so you can also see here like common anode and common cathode. Again, based on the driver IC we have to choose. So let me choose here a red common anode. Okay, so just say okay. So let me start with the display. Common anode means we have to connect here positive power. So I just go to the intersheet terminals, power, and I connect here. Like, let me test like how it works, and I want to identify which is pin number A, B, C, like that. Okay, so what I do is I connect here power, and the ground I just keep it here and just connect directly. So when you run, you will see, this is called segment A, segment B, C, D, E, F and G. So you can check that it will be in order. So the last one supposed to be this one. Okay, whereas when you look at the real time, in real time the component will have actually 10 pins. You have to follow up again with the data sheet to identify what are the pins and all. Okay, now so we are with the display, and then I'm just going to choose again I'm going to place the components. So let me choose 7490. Then we go ahead with up and down counter if time permits. Okay, and I have the display driver also here. So this is for A. I connect once, and look at here, once the wires are equal length, once you connect and go to the next pin, just double click, automatically the wire will be routed. Okay, but it must be same length, then only this will work out. And I believe this will be LSP. Anyhow, we will check it out that, and just connecting here. Okay, and then I need to know about these pins. Okay, it's a quite long time I worked with these ICs. Let me go to the data sheet. Well, we are with the data sheet here. This is a data sheet for the decade or divide by 12 or binary counters. That means which can count up to 16. Okay, it's a common data sheet. And if you look at the truth table here, or function table, how to make counting, the 4 terminals, these are the conditions. Okay, so when you do this condition, that means high, low, and don't care. X is called as a don't care, anyone, that means high or low, the counter will get reset. That means all counts will start from 0. Okay, whereas we want to see the count going on, that means I can connect all of them to low. It's possible. That means what I will do here now, I will just group them all. Okay, and I will just place a ground terminal and I will connect here. And regarding 7447, this is all called as a lamp test and hiding the leading 0, things like that. I believe this active low. Okay, so if you connect this one to ground, lamp test will happen. Lamp test is nothing but when you make this pin as a low, you will see here number 8. That means all segments will be working. It's called lamp test. But what we are supposed to do now, we have to connect to power. Okay, so let me just rotate this and connect to power. Okay, and also you need to refer regarding this clock A and clock B, because it's internally they kept it for achieving different counts, so they made it separately. You can see here, clock A is a master clock. From QA we have to feed back to clock B. I think I have already some other reference circuit also. Yeah, this one. Okay, so what I will do is clock B, we are feeding with this, and I have to feed a clock signal. Again I am going to the generator mode. I am choosing the pulse. Okay, and then I am just connecting over here to the clock A. You can see here, initial low voltage 0, pulsed high voltage 5 volt. These are the TTL ICs which works with 0 and 5 volt. That means we say 0 and 1 in digital language, and the duty cycle is 50%, the pulse width, and the frequency is 1 Hertz. That means we can visually see the counting on this. Okay, and one more thing I want to tell you, these are actually 7 LEDs and there will be a decimal point. Obviously there will be 8 LEDs on this package. If you feed directly without a current limiting resistor, the display will go bad. Again in real time design, you have to provide a resistor on each pin, then only you can safeguard the display. Otherwise, in a very first instance, the display will fail. Now just let me simulate. So you can see the counting is going on. Nine, and then again it will roll back to 0. Whereas we need to we need to have a 2-digit counter. So once you are done with the single digit, just try to save the circuit and then select this portion. Let me say copy, and I will have it copy of the circuit over here. That means you can see the Proteus is automatically putting the numbers for the new ICs like U1, U2 and U3 and U4. Just listen carefully. We are feeding the clock. This is my LSB count and this is my MSB for the counter. From here, that means whenever this counter overflows, I need to start my counting. Okay, so there is a difficulty on getting this connection. So what I will do, I will just pull this circuit little bit so that we can do this connection comfortably. Okay, now this will count 0 to 9. Then you will see there is a increment here by 1. Okay, so just imagine in a real time, people they design by using 7-segment displays. They will keep this full circuit behind the scene and they will keep only these displays like one after another. I will also show you how to do that. Okay, now let me increase the frequency. Let me make it as a 3 Hz so that the counting will be a bit of faster, and I just run the simulation now. Okay, now this is ones, this is tens, right? So what I want to do is I want to just keep the display over here. Okay, so what I will do now, one thing you can do, just you drag this one and just place it here. Of course this get connected automatically and you will see that effect. However, this is not actually a structured diagram. I will introduce it to a new component. To delete a wire, right click twice on that wire. Okay, so the wires are deleted now, and just place over here this component, and then there is intersheet terminals which we are using for power and ground. Go to the default, place here 7 of them for 7 segments, and again rotate this and place here 7 of them. That means though you broke or you disconnect these wires, still there is a connection, like we are going to create a connection with that. As I told the rule, just double click, okay, and over here once, and then continue with double clicking. Okay, and just name it. For naming, right click, left click, just make a letter A here, that means segment A, or it can be any name as you like. Okay, and B, C, well, now once you name here, again right click and left click on the place where you want to connect, you will find out the names which you have labeled. Just choose one after another and the link is created now, and just run the simulation now. You can see how it works. Okay, so we are done with this portion. That means I believe you understand like how to create a simple counter and how to display the count on the 7-segment display, and also you understood about how to have a separation in the connection. Thank you very much. Thanks for